So this video is a quick summary of atom economy where we'll go through one worked example and some of the theory. So atom economy is obviously to do with atoms. Now, in order to minimize waste whenever we do chemistry, what we want to do is make use of pretty much every atom that we put into a reaction. Atom economy measures the mass of the atoms in the product that you want, that you get at the end, relative to the total mass of atoms you put into the reaction, which sounds rather complicated, but you'll see it's quite straightforward. Now, one of the biggest challenges is to try and design a reaction that makes use of most, if not all, of the atoms from your reactants. Because if we can achieve that, we are able to end up with sustainability. So atom economy is the mass of product you want as a percentage of the mass of all of the reactants that you've used. So for example, if we look here, we have two reactants and they are producing products. Now, most reactions produce two products. Typically, one of the products was a chemical that you wanted and the other one was a byproduct. In this instance, we can see that of all the products we produced, about 50% of it was the stuff that we wanted. And that leaves us with an atom economy of around 50%. Now the equation for atom economy, or for percentage atom economy, is in your data booklet. So again, you do not need to memorize this equation. It's on page 3 or 4. And it is the mass of the desired product, it's usually only one product, divided by the total mass of reactants. And then you multiply that by 100. So it's a measure of the proportion of the reactant that is included in the final product. And a reaction can have a really high percentage yield in terms of it makes a lot of the product that you want, but it can have a low atom economy in that actually there is a byproduct made that is also made in lots of amounts. So atom economy and percentage yield are not really related to one another. They're just two different ways of measuring the efficiency of a reaction. So any reaction that produces only one product has a high atom economy because it means it has an atom economy of 100% in fact. Because if you have 2 or 3 reactants that come together to only make one product, that product contains all the atoms from all the reactants, therefore it's 100% yield. 100% atom economy, sorry. A lower atom economy is a situation where you have 2 reactants producing 2 products. Because only one of those products is desirable, the other product is a waste of atoms in the strictest sense. So you should know automatically if a reaction only has one product, it has a really high atom economy. If you've got more than one product, then you are going to be able to calculate or have to calculate the atom economy. And we're going to do one worked example now. So what is the percentage atom economy for the following reaction for making hydrogen? So it's for making hydrogen, which means that hydrogen is our desired product. So this is desired. It means that this one we don't care about. Okay? Now remember, it is the mass of desired product divided by the mass of all the reactants. So the first thing we're going to do is get the GFM of everything. GFM. Carbon is 12, water is 2 times 1 is 2 plus 16, so that's 18, and H2 is 2. Now, you do have to see if you've got a number here and you've got a number here. You do need to make sure that you multiply the GFM by that number. This is the only time where I would ask you to use that molar ratio value in relation to the GFM. So here we're going to have to multiply that one by 2 because there's 2 waters reacting and we're going to have multiply that one by 2 because we're making 2 hydrogens. So then what we do is we do the sum. So we've got 12. This is 2 times 18, which is 36. And here is 4. Now that is our total mass of products. We need our total mass of reactants. So we're going to add them together, and that is 48. So we've got 4 and 48. Our atom economy was mass of our desired product divided by mass of reactants, of all reactants, and then we have to multiply by 100 to get it as a percentage. So that was 4 divided by 48, multiply by 100, and this comes out to be 8.33. It's actually 8.333 recurring, so you could put the dot there if you wanted. But 8.33% to 2 decimal places. So you can see atom economy is really straightforward. You only need to use GFM. You don't need to work out moles. The only tricky part is to remember that if in the equation you do have a number in front of the chemical, you have to multiply the GFM by that chemical. And this is the only time where you do multiply the GFM by that number in front. Okay, so hopefully that is a nice refresh or summary of atom economy for you.